Right. Thank you very much for coming back. I think we are going to start the second part of the morning, which is a bit more varied in the type of approaches that we are going to have. And to start with, then we will have Pierre Alexandre Tremblay from colleagues from University of Huddersfield. Creative coding versus large sound banks, fostering divergent thinking for fluid corpus manipulation.
Thank you very much. Obviously, as everyone said so far, thanks for organizing such an event. As the project is young-ish, I decided to share the presentation between me and my co-investigator. If it hadn't started, I could talk about the dreams, but it's 9 months old already. So my dreams have already started to deflated and panic to raise. But it was good yesterday to hear Mr. Serra and Mr. Pache talk about these idealist traits that start these projects and now they're confronted to reality. So we'll talk about the project, its aspiration, an overview of the methodology. That's me, by the way, PA. And then we will cover technologies to be explored, early publications that will be done by my wonderful partner in interactive music listening. And then we will talk about the taxonomies and the early publication and the early plan of a first plenary by my creative coding partner. And finally, I'll try to wrap it up in something that almost makes sense. So, what is Flucoma? What is the project? First, we need to talk about its context. So my research is in creative computer composition. And therefore, my research is in trying to find unheard of music beyond a technological demonstration. And for those of you who have attended technological conferences, we often have demos of very little aesthetical interest, but they are very important as seed for new research for people like me, because we need the tools to be, to be critically managed and criticized to allow new approaches, new musical ideas, through the new digital tools as creative entities, and also through new contributors, because as you will soon see, the world is a great thing. So what is that specific project that we've had? What is Flucoma? But fundamentally, I've decided to focus on a specific challenge of our field. And the specific challenge is the large sound banks that we all have. You buy native instrument, to use a commercial example, and it comes with a hard drive full of sounds, most of them very uninteresting, but with their own taxonomy that they've put on it. And if you go on free sound, you have much more rich, much more diverse, much more challenging amount of files. So they are hard to grasp, especially if we try to see them in an abstract way. So my hunch was that a higher level of organization is potentially extremely rich. We could be fluid, we could be user-led. Not everyone wants to approach the same sound the same way. It could be transversal and multiplicative. As you explore your database, you might generate more material by looking at it through different criteria. And it could be synthetic in the sense that you can cluster material that if you have 600 hours of sound to analyze, or even a single hour of modular synth noodling, that might be difficult to actually just suffer and do an objective taxonomy through like hours of gritty noises. So the two contextual elements that allow that research to happen today is that you have first an ever-expanding gap between our two research communities in computer composition. On one side, you have the techno-fluent generation. I'm just young enough or not old enough to have known the world understanding what internet could be. I'm very fluent with technology, in all modesty. I'll tell you what I'm not good at very soon. And the computers, this machine is much more powerful than the computer who sent the man on the moon. Even your watch is probably much more powerful than that. That's what we have as affordance for my field. On the other side, scientists have done their job, and therefore, the advances of DSP are beyond the reach of a somebody who can have my type of training, which is in critical computer composition. Now, I'm not saying that everyone is beyond that reach. I can count 2, I think, in the world who can do actually top-end research in DSP as well as interesting music. But for me, this is where the crux is. They have an immense community of composers who can do a granulator, who can do some basic FFT processing, are very fluent in Max MSP or Super Collider, but they lack the postdoctoral level research to encode their own deep neural network, or just understand the concept, or just know how to map stuff to it. It really is abstract. Yet, if you take time to explain to them the basic musical concept at a non-mathy level, they are able to play with them in very interesting style. The second element that allows this kind of research is the fact that researchers in computer composition are more and more decentralized. And you have new model of iterative interaction. You have huge online communities, most of them non-academic, most of them more interesting than academics. And, oh, sorry, I shouldn't say that here maybe. But a very interesting, they can provide a new perspective and divergent. So this is what my field is good at, is to see at old problems different ways. And this community is fantastic because it doesn't have necessarily the same rut than we all have going through a single training, which is, I have to say, challenged in the last 15 years of education, but still quite present. So, the Flukuma hypothesis, what is it? Where do we go? So, it's to bridge the gap between these two communities, not asking any of these communities to do something that they already do, but to have a third community or something in the middle to facilitate the bridge, and especially in that case, to bring the digital processing advances to creative, techno-fluent composers. Seeding the right tools at the right level of granularity, and to allow or foster different thinking about large corpora, to observe and to newly segmentation, new taxonomies, and new remixes, variation. There's a lot of things we can think of doing at blunt level, but we don't have access to the tools in the current situation. So, to explain where my research stands right now, I need to play you some music or some sound. So, first thing first, for the half of you who do DSP, I'm sorry, this is very dumb. For the half of you who don't understand computer, I'm sorry, this might be too complicated. That's the problem. So, half of you will know about impulse responses, raise your hand. Okay, 2/3. So those of you who don't know, an impulse response sounds like this in a room. And if you have a bigger room, it sounds like, it looks like a DJ now. No, not this, that sounds like a piano. Sounds like this. Much bigger room. And the previous project I did was to try to take the sound of a room with speakers that usually sounds bad in mixed music, and compared to what pop people do in the high-flying pop touring, they can do some very crazy system calibration. Sadly, these systems are very rarely available in 17 inputs, 23 output systems. And there's the kind of music that we do in mixed music, location, speakers, and all that stuff. So I say, we can port this. That science is relatively old, so you take a problem, you inverse it. I know it's not perfect, I know lots of research is going to make it better, but could we please have the tools at basic level? So, example of putting a dry piano, as you heard earlier, through a convolution process, we can put that in the room. Very exciting, no, actually very boring. So, but to get that in a stable manner way with the artist criterion, it has to be perfect, work all the time, and etc. This was not available. It was available in the in-house earcam object, which obviously was in-house earcam, which is not helpful for the rest of the community, which is out-house, not earcam. So what we said is, let's make that project. And the genius of my previous postdoc, he said, actually, what we should do is not make a PA wants an object to correct the sound world, but we should granularize it in different objects, the capture of the impulse, and then the application of the impulse. And suddenly I was able to think divergently with convolution in real time in my real environment. So for instance, the kind of sound I really like, that. But if you convolve that with the piano, but every time you have an attack, the piano is sampled at a different place and that becomes a kernel, a sound that is colorful whitish impulse that convolves with a sound that is harmonic tonal, I call it autobjork. that's beautiful, I think. So this is where my research is interesting, is that I was able to put that together. I had a musical idea, put that together in 25 minutes, and I had something I could work in real time, adjusting the threshold, adjusting the kernel, playing with it, us do whites, do this. My creative workflow, which is quite techno-influenced. So the key conclusion is that quick, versatile access to tool allows me to do my research properly. So promising technology. Around here, I see signal decomposition. It allows me to divide sound. I'm not a scientist, so I see that. I receive that from papers and demonstration. I see, wow, I can chop the sound all automatically instead of doing manually. I can do some kind of separation of noise that you have in some software. Like, for instance, what we just heard here, there's a great voice component, just the pitch. That if I decide to process just the pitch in a kind of interesting, expensive manner, sounds like this, which I again find very beautiful. And if I was not doing that and take the same processing and put all the sound in it, it sounds like a bloody mess. Which I have to say I find also beautiful, but a different type of beauty. So it allows me that kind of stuff, and it was interesting. The idea of large database mining, large has got commas because I'm not talking about Google large, I'm talking about composer large. When you spend an hour indexing, when you spend 5 hours indexing sounds around a single thing, you start to see cross-eyed in your own material. So having ways of abstracting it was very interesting, and all these wonderful keywords. And all of that technology is available to the lab. I know now, 9 months in, you've got SciPy, you've got all these wonderful things, and I'm learning stuff left, right, and center. So the methodology, the methodology is very simply this idea of designing toolboxes, one in signal decomposition, one in corpus management, and then release that in 3 progressively wider, first the local, and then after that we have 8 world-class techno-fluent composers who's going to do that and to play with it, and finally, obviously, open source to the whole community, but also with knowledge transfer material. Now, the 2 very clever person on my right will present you first the technologies in a much more interesting way, because 9 months in we have better ideas, and finally, how we can critically work with them. Gerard.
Hello. So I'll present very quickly. There's a slide missing here. Yeah. So about the actual implementation of these ideas. There are a number of challenges in how to do this for real. So first of all, we're trying to make software that can be used by musicians and artists, and as famously put by William Buxton, this is actually much harder than even doing software for military. It has to really be very robust, never crash, particularly not in the middle of a performance. It has to sound good, even if the underlying models are imperfect approximations, and it has to finish anything in a reasonable amount of time. So speaking of which, normally we want things to run in real time, but many of these things that Pierre was talking about are really not possible to run in real time, particularly if we, for example, want to search for something in a long recording. We actually want it to finish without listening to the whole recording. Similarly, there's different ways to implement recent signal processing and machine learning algorithms, mainly either in an unsupervised way or in a supervised way, that have implications as well in terms of how fast they will be and how accurate they will be. And finally, there's the issue of how to organize the different operations that we need to perform, or that the user may want to do on the audio. And this is actually quite complicated, so we're actually relying on existing software environments, namely SuperCollider and Max MSP, that a lot of people in the community, at least of electroacoustic music composition and performance, are already using. So here's the general idea for the first toolbox. So the first milestone, we're aiming to create a toolbox for decomposing recordings into pieces. And And this is not meant, it might be a bit misleading, this is not meant to all run at the same time. Rather, it's a collection of, it's more like a Santa Claus letter of the things that we want to have for this first milestone. And they all share a common infrastructure, so they all run as objects in these environments, in Max or SuperCollider. They all process, they're all spectral processors of buffers, of audio buffers. And then they all produce some sort of decompositions into either temporal segments or different frequency regions, or a combination of both. And we also doing some analysis of so what is called feature extraction, and we hope that this will be a bit like the interface that a user can have in their environment. They can visualize audio based on some features that we can analyze, and then get a glimpse of what's going on and what does the input look like, what does the output look like, and stuff like that. So I'll highlight it in black. So this is a combination of existing technology that we're implementing and also some new research that we're doing. And so I'll very briefly go through in both phases some of the things that we've been doing in these first 9 months. So one was to attach to an existing community that does source separation of music, polyphonic music. And in this community, they found it very useful to reduce the problem to something where there's a common set of instruments that generally apply only to mainstream, kind of mostly mainstream pop music, I would say, and other genres, but things that are done using vocal space, drums, and other means, guitar, keyboards, and stuff like that. So by reducing all the possible instrumentations to these and labeling many songs, they've been able to apply what's called supervised methods and improve quite a lot the result for this very difficult problem. And here we've proposed a combination of two existing methodologies, which is convolutional neural networks and what is called fully connected neural networks. And we propose just another architecture that basically we're using convolutional layers for the input, so to provide a bit of context in order to predict a separation of different instruments at a given point in time. Excuse me. So I think I'll have to be a bit fast, but yeah, so the results, I would say, were competitive in terms of the state of the art, and also with our requirements of maintaining the possibility of a real-time implementation and also being completely open source and reproducible. But still, this idea of labeling, relying on let's say social conventional labels is a bit challenging especially for different types of music, and particularly experimental music where there are no vocals and no bass and no drums. So we're still looking at the idea of supervised learning in this case. Is very promising for implementing things that can run in real time and fast, but it's still very difficult how to design them in a way that is useful for many different applications. Then another example is more unsupervised and therefore more flexible method. This one relying on two different traditions. One was the sinusoidal modeling, and later including transient modeling, that was, I would say, worked very well for things like instrument sounds, but sometimes it's a bit more challenging to apply to polyphonic music, for example. So in the polyphonic music separation community, there was another idea, which is the harmonic percussive model. And both kind of signal models, I think they're not converging, but they're creating a space in between where we try to do things that kind of work, and we called it transient versus stationary separation. And here we propose to use another neural network that we tell to create an output that is sparser, and therefore with less information than the input, and we apply to to direct it a bit in which direction it loses information, we apply some constraints using in the harmonic percussive community that enforce or that promote straight lines in the spectrum. So horizontal lines promote steady components and vertical lines promote transient components. And yeah, so here I think I could play you an example of this one. All right. Okay, so so this it still doesn't work very well for polyphonic music, but it works. It does produce very interesting results for monophonic instruments, and particularly the idea of enforcing sparsity provides an intuitive control for this kind of operation. Finally, we've been working on the idea of visualizing descriptors for the user interface, as I mentioned. So here, there's plenty of research on analysis of sound that has been used for kind of machine learning research, but we think that there's a lot of potential for using these descriptors in interactive environments. Hopefully, some of them have intuitive enough interpretation. And then for doing this, actually, you need a few operations, like you really need to release sample, you need to scale the descriptors, and you can also do things like combining them. So we propose a kind of set of operations and a kind of domain-specific language for doing that at the moment as a JavaScript library. And so here are some examples of operations that we can do with that. If you've seen, for example, the Freesound poster, if you know about Freesound, you may have seen this kind of waveform displays that use spectral centroid as a way to color the waveform. So this is the same example at the left, but we can extend these and apply many more descriptors. So for example, at the right, top right, it's applying amplitude to kind of create this kind of decay effect in the waveform color. So the second example is how to use combine several descriptors to make a kind of interactive segmentation to kind of isolate interesting events in a given recording. The last example is a bit more creative use of this library for looking at how to create graphical representations that can be used for identifying different fragments of otherwise kind of complicated sounds. In this case, there are sounds of a cardboard that Owen used, and you'll hear it this evening in the concert. So I'll let the rest of the time to Owen.
Hi, right, okay, I'm going to do a very superficial bounce over the top of this because I think we've been confused about time. Like Pierre, I'm a practitioner, but I'm the kind of practitioner that likes to climb inside algorithms, so I sort of act as a chaotic bridge between Gerard and Pierre. As well as the software, one of the aspirational outcomes for the project is a community, and obviously that doesn't happen by magic, so in the middle of that is some kind of set of knowledge mappings that allow musicians to start to get a grasp on where the musical potential of some of this stuff is. So you could think about Trevor Wishart's work in the 90s, providing really musically led examples for getting to grips with FFT processes. And of course, that's all entanglements and complicated and tentacles and which is great. It's going to be quite a complex process of actually devising languages and getting, I think, a good agonistic kind of dialogue going between disciplines. We, of course, have lots of starting questions, which I'm going to run up in reverse order. The first thing is to burrow into this idea of what techno-fluency might actually mean. And we sort of characterize this as a set of dispositions. So they're not sort of genetic traits, they're kind of moods, almost. So people can obviously learn their way up a degree of technical sophistication, but depending on where you are in a project, you're more or less inclined to burrow into technology. So you might be quite fluent, say, in C++, but for the purposes of a gig, you don't want to go there. And by the time you're getting to mastering, you don't want to leave Pro Tools. So the point is to try and characterize our prospective users, not in terms of putative ability, but to assume that they're all clever, motivated people that will have different needs depending on different musical jobs. As far as community building goes, the first step really is to, as Pierre said, get this widening set of interactions going with the practice-led research community. We have these 8 composers. They're going to start proper commissions in September. not demo pieces, proper commissions that will go to an international festival. We want them to concentrate. We want them to give us proper feedback and throw us curveballs and challenge our design ideas. So I've got a set of interviews that I did last month, still transcribing those. This idea of disposition seems to work. It was interesting to observe that different traits seem to be there between people that like to make an instrument and stick with it for years. Other people like to practically make their instrument in the sound check. Other people have catalogues of sound that they live with as part of their instrument. Other people will make a whole new set every time they start a new project. The second sort of taxonomy to burrow into is this idea of divergence. Here's a manifesto. Extensions, not replacements. Machines are there to augment us. They're not there to replace us. Who is interested in the idea of a machine making music? Certainly not musicians. Artifacts are a form of ear training. Philosophy of technology for all. So, the point is that to be musicking is to be humaning. Apparently, I nicked that off someone. I still can't remember who. Imperfection itself is a form of material, as you've heard in Pierre's talk. Hearing is a diachronic practice. We have to learn to hear what the artifacts are and where their musical value might be. Interface isn't just a neutral matter. It forms our conception of ourselves as musicians and as humans. So I'm hoping that what will come out of this is perhaps a methodological basis for a kind of practice-led design for artistic research. There's your kind of standard paradigm. You have a theory, you apply it, and there's a kind of implicit evaluation. Maybe we could have something like this, where practice is allowed to, within the research process, explicitly disrupt theory.
Any questions? Oh no, actually my timer says 26 minutes. So the conclusions, I'm sorry, did we start on time? Is it 25? Okay, so I will skip the first question and give our conclusion, therefore preempting your questions. It's a bit early for results. We have DSP methodologies, papers coming out. We have musical works embedded. You can go on the website to see that. We have digital debris, which is very important for me to leave trace behind commented code, simple code, complex code, to create a kind of buzz, but also a community of interaction from the outset. And finally, hopefully we'll have new musical ideas and sonic possibilities. It certainly has challenged mine, new research emerging from thoughts, and hopefully, if I'm a very big idealist, a renewed decentralized dialogue between disciplines. Thank you very much.
Thank you very much for making the effort of cutting your talk from 30 minutes to 25, which is really what should be, to give some time for people to make any questions or comments.
Well, thank you very much. It was very interesting. Thank you for this very interesting presentation. I'm a total layperson, but of course, in a way, you are creating the raw material for musicologists of the future.
Actually, that's my colleague Michael Clarks who will present tomorrow. You should watch what he's doing.
Musicologists of the future, very good. I wondered, how do you structure your interface to the practitioners of music, composers and musicians?
Actually, the trick of this project is to tap in a community that is already has its own interface. So the community around Super Collider is in the 10,000s of users. The community around Maxim SP is in the hundreds of thousands of users of different level, and that's already a given interface. So what we try to do is to augment these with new knowledge, but we buy in their techno-fluency already. We're not going from scratch to techno-fluent, we're going from advanced creative coders and adding a palette, an element to their palette, and see how that influences their palette. There's also a musicologist observant looking at us as rats, incorporating that tool in our already quite complex set of tools, but not as interesting as these new DSP possibilities.
Are these people inside academia, some of them? Or
some of them are, yes. Actually, the problem with that community is it usually is too much in academia, and the great thing of what happened in the last 20 years, it's actually exploded. with Max for Live being included in Live, some people start to open that box and suddenly there's a world. The PD community has invaded a kind of art world, or the other way around. The techno-fluency of that kind of digital native is everywhere. You can see that. It is very broad, but to start with, as I said, we unfold. So we start with us, with our biases. We make sure we don't have too many. 8 composers from 8 different backgrounds, some of pop music, some in academia, some in experimental noise. And then you can see all their names on the website. And then finally, the wider public.
Another question?
It's probably the last one.
Yeah, the last one, yeah.
I'm going to be her chair, so we just lay the chair tags in.
Thank you very much. Is there any attempt or perspective to open to collaborative practices around the coding work? I mean,
yes, these environments are already have lots of practice of collaborative coding. I don't know at which level you mean.
If you will let people collaborate directly, so through a kind of GitHub or this kind of stuff.
Definitely, everything is on GitHub already. Everything is free. Everything is going online as we go. And there is when it's artist ready, it goes on the Max list. But before that, it goes on GitHub because that's the geek list. And then by now it's Microsoft evil list. But anyway, so it's going to different levels, but it's all open to collaboration. And we are not reinventing the wheel. We have found great tutorial material for the techno-fluent who stop at DAW Ninjas to learn about machine learning. Like Fibrings, if you want to learn about machine learning at a low level of techno-fluency, Fibrings tutorials are fantastic. I'm not going to do more. It's not relevant. But what I need is a central place where if you have a certain techno fluency and you have a musical or technological question, you can be pointed in the right direction. So the curatorial element of knowledge transfer is important, but definitely open to suggestion. Bring on your code.
Thank you very much. Now is this odd moment in which the chairwoman goes to be the speaker and the speaker goes on to be the chairman.